would even start with that one.
All right, guys, you ready? Yes. If you're sitting in this room, you're ready. So chapter 9, which one, sorry?
9.2, number 66.
Bless you. Oh, all right. So we did talk about this a little bit quickly, so just pick one out of here. Sure. Let me just pick one out. So one of them says this. This is on number 66 in section 9.2. Guys, 66 says, I'm going to pick out number F. Number F. Good old number F. Good job, Jeff. Any number of cars a person owns is not more than 10. This is throughout their lifetime, right? This is a claim somebody made. The number of cars a person owns in their lifetime is not more than 10. I have a problem with that word owns. I've had cars that I really didn't own, but I never did own because they died before I finished paying. In math, what's the claim being made? What? Yeah. It's very specific. It's not more than.
Less than or equal to.
So it's got to be the leftover is less than or equal to. It's not more than, so the only thing left is less than or equal to. Now, why am I doing that for myself? Because the types of errors depend on what the HO is. I don't know if you guys remember that. So type 1 error. This problem is all about type 1 and type 2 error. What's a type 1 error again? Do you remember? Short phrase. So the HO, the null, could either be true or it could be false. So a mistake I can make is if it's true and I say it ain't true. If I reject a true null, that's a mistake, ain't it? So if I say, no, you're wrong, and the HO is actually right, oops, I made a mistake. And there's just no way we could know. There's really no way to know. That's that % chance that I'm wrong. Reject a true null. I like it. So which one is this? This is the HO or the HA? Or the H1, sorry. HO. And what's the H1?
Greater than.
What's the opposite of this? Greater. All right. It's not really necessary for this problem here. So the type 1 error would mean, what is the situation with this? Is it true or not? For the type 1 error, this is true. And we think it is false. That's it. So if you can capture that in words, you have answered that question. Because it says, state the type 1 and type 2 errors in complete sentences given the following statement. So can you state what the type 1 error would be? That this is actually true, and we think they own more than 10. Right? You guys see, be a little more explanatory than
I'm still lost.
no? Okay. So what's a type 1 error mean? That the null is true, but we reject it. So that means that this is actually a true statement, but we think that they own more than 10.
Okay, so
We reject this, but this is actually true.
why did you cross out the high?
Because it doesn't matter. It doesn't say anything about the high.
Oh, it doesn't matter. Okay.
It's all about the whole, but I just did it just to make sure we knew how to write it.
Okay.
Yeah. The type 2 error would be the opposite of that in a way. The other thing that the HO could be is false. And what mistake could I make then? Rejecting it would be a good thing. Wouldn't be a mistake. If I rejected a false null, then that's beautiful. That's not a mistake. So a mistake would be to fail to reject. A false null. Oh, I know. But, just keep referencing that. So say in reality, the mean number of cars a person owns is not more than 10. So that's for the type 1 error, right? But we think it is more than 10. That would be a type 1 error. Type 2 error would be, in reality, the mean number of cars is more than 10, but we think it's false. We think that statement's false. We think that it's less than or equal to 10, yeah.
It doesn't quite make sense, but I think I got you on it, but that's okay.
Okay. I mean, at the heart of this, if I am making statements about somebody's claim, if it's true or not, then there are two mistakes I can make. I can say it's true when it's really false. I can say it's false when it's really true. That's all those errors are all about. That's it. That's what those errors catch, is those two possibilities. Type 1 error probability is alpha. Alpha is the type 1 error probability. So it's a little bit freakier to get the type 2 error. It's not just 1 minus alpha. It's a weird thing. It's the strength of the test, and it's called beta, which makes sense, alpha and beta. So type 2 error, if you make this one get smaller, you make this one get bigger. It kind of makes sense. You can't get everything something for nothing. If you make one better, you're going to make the other one worse, and vice versa. So it all depends on which one is worse to make, which error is worse to make. It's kind of related to the whole thing about if you're sitting in a nuclear reactor, the thing blowing up is the worst error to make. So you can control that probability. You just get off your ass before the needle goes too far. Okay, maybe. We'll see. All right. Anything else from homework? That was a good question. Oh, by the way, I think I said this quickly in passing before, but there's a reference to a sheet in the back of the book that they want you to use for the hypothesis tests. Screw that sheet. I think I said this before. Just use the 5 steps we use. They use more than 5 steps, and they do things out of weird order. Just do the 5 steps from all those handouts I've given you. You should know those 5 steps by now. Does that make sense? If they say use the sheet in the appendix, whatever, say, screw you, book. Once you actually say it. And then just grab a worksheet and do the 5 steps that we did. Cool. I like it. Again, maybe. All right. Anything else from homework? Okay. So here's what we did last time. So I normally do this work on the side, right? Sometimes you'll see a formula written this full way out. So let's just put it in there. It's easier to not have fractions inside of fractions. But what we did last time is we said, what really happens in real life is I don't just have one sample and some known average. What happens more often is I don't have a damn clue about anything. So if I had just made a brand new drug, and I tested it on mice, and it looks okay, and I'm about to test it on humans, I don't have a clue what the average time is going to be. I don't have a clue what the standard deviation. I have no idea. So normally what we do then is we have 2 samples at least, if not a third control group that doesn't get anything, those poor people. All right, so let's just stick with 2 right now, because 3 requires further statistics than we've done. Uh-oh. So we I get drunk off the stats. So we got... of course, a group of people that gets the actual drug and a group of people that gets the placebo, and we can compare the 2. So we get 2 sample means, we get 2 sample standard deviations, and we don't have a clue what the hell this thing is. Right? So just to move us along, last time we did this whole thing, I tried to make sure that this makes some sense. So instead of 1 sample mean, I have 2 of them. Instead of 1 population mean, let me just get that out. I have 2 of them. And I talked about the math between these 2 steps, but instead of 1 standard deviation, 1 variance, really, so I can say this is the same thing as that. Yeah, there is. We have 2 variances. So everything that was there has just been doubled because I have twice the information. I have 2 sample informations for each one of those things. Yes, sir?
You said that's always 0, right?
This piece, exactly. So this piece, not always, but for us it will be. For us, the null will always contain some kind of equal sign. Right? Some kind of equal sign. And if mu1 equals mu2, what's mu1 minus mu2? 0. So this piece goes away. Now, in reality, our claim could be the average for men is 9 more than the average for women, and then this would be some kind of 9, depending on which one I called men. You see, if this was men and that was women, then this would be 9. Does that make sense? So we, for whatever reason, we just don't do that kind of problem. So this is basically going to always become 0. So the nice thing about it, I really like to think about it this way. If I take 2 samples, and I really want to show that my new drug obviously does way better than a placebo does, right? And so I average the pain level. Let's say if you take my new pain reliever. What do I want to have be true about my sample of people that got my actual drug versus the people that just got a sugar pill, a placebo? What do I want to be true about those 2 average pain levels? Do I want them to be about the same? That would suck, wouldn't it? That's why I'm fighting against these being the same. I want to show that they are not the same somehow. In this case, I want my pain level to be less than the other one, right? Don't I would hope. Well, it'd be nice if sugar could make us, well, actually it can't, but talking about real pain, right? So that's why I like to think of this as, are my 2 samples far enough apart? So here I'm saying, is this one sample I took far enough away from what they think the middle is? If it's so far away, then that middle can't be in the right place. That's the whole idea of a hypothesis test from chapter 9. Chapter 10 kind of reformulates that and says, not some given middle, but are these 2 means far enough apart from each other to say that they are not equal? That's a nice way to think about this. That's why I take a difference between the 2 means to see if they're far enough apart. Okay, if this came out to be 0, what does that mean? That they're the same. I wouldn't even have done the problem then. I would, oh shit, I got the same pain level stuff here. That's no good. My pill doesn't do better than a sugar pill. That sucks. Back to the drawing board. Maybe I discovered a new sugar. I don't know. Gotta test that out. All right, maybe. How you guys feel? We did an example problem last time. I know it's been almost a week since we did that. I have another example one here. I'll tell you what, let's do one together, and then I'll unleash you on this one. So let me just cut this one to the chase. Let's say we take a sample of men. We take a sample of 47 men. And we find a mean of 11, a standard deviation of 4.1. And women, take a sample of 42 women. Now, I think we talked about last time about the degrees of freedom, right?
We did.
Yeah, we did? All right, good. So in general, the degrees of freedom is going to be n1 plus n2 minus 2. That's right, I remember that. We talked about that. There's actually a more complicated formula that is truly just disgusting. This is an acceptable alternative method if you have some evil teacher that makes you do stuff by hand. So this is the given information. My claim is that let's say that the men's average is less than the ladies. Now, I know I keep asking this kind of question, but I continuously have to remind you guys, why can't I just stop right here and say, yeah, done. Right? 11 is less than 12. So why the hell do I have to do all this shit?
It's not far enough.
far enough away from that to
Well, we don't know how far away it is, but right. So I like where you're going with that. We have to show it's far enough. Well, why? 11 is less than 12. It's only a sample. So this statement is about all men. Right? I could say that my sample of men definitely have a lower average than my sample of women, sure, but I don't know about all men and all women. So if I take a sample of anything, will the average of that be the same as the population average? Do you think, how often do you think that would happen? Not very often. Does that make sense? If I take a sample of Grossmont students, just a random sample, and I compare it to the actual average age of all Grossmont students, I would put money on them not being equal, right? As long as you don't round it too much. You guys kind of with me here a little bit? So any sample I take is definitely going to be different from some mean, the population mean. It's going to be different. But so to be evidence, it's got to be really different. And that's why the rejection region is always kind of so far away. You guys understand? So like 2.575, 2.33, whatever the hell it is. It's really far away so that it shows enough evidence. Okay. So let's call men 1, just because they were stated first, and we'll call women 2. So you got to choose that, and then keep it the same throughout your whole problem, or else you're going to have the thing on the wrong side, the wrong tail. How do I state this claim in math? Ish. Mu 1 less than mu 2. All right, cool. So then I know that HO is what? And H1 is what? Which one is that, HO or H1? H1. It's the high because it doesn't have an equal sign. So what's HO going to be? Greater than or equal to. I like it. How many tail tests will this be? 1 tail. I just want it less than. I just got to find a difference down that way. Boop. 1 tail. I like it. All right, second step. The steps don't change. Just that's really nice. Second step is, do I use Z-scores or T-scores and why? Yeah, what 2 things tell me I use T-scores? Yeah, we don't know sigmas. A little more importantly, what's true? Why is it normal? N1 and N2 are greater than 30. So it's normal enough. Let me stop there for a second. See, that's nothing new. The only new thing is the formula is a little bigger. Why is the formula bigger? Because it's got more stuff to put into it. It's got 2 samples worth of stuff. Jam it in there? So now, this third step, so now I know what I'm talking about, I know what I can use to talk about it. The third step is going to be, what is going to be enough evidence, right? The rejection region. So here's where I'm going to tell you, use alpha equal to point, oh, what you got, Jeff? I don't know, Jeff. 0.05. So alpha is 0.05. What else do I have to know for T-scores? Alpha is 0.05. Degree of freedom. What's the degrees of freedom? Yeah, 47 plus 42 minus 2. 87. And your chart only goes from 80 to 90, right? So we're going to use 80. To be more conservative. Conservative. If I really want this to make sense of the smaller alpha is that a harder or an easier test to pass, like to get into the rejection region? Is it harder or easier? Harder. So if there's some part of something that I'm not sure about, I'm always going to err on the side of making it harder to pass because that's on me. So I don't know what 87 degrees of freedom is, so I got to use 80 to make it. That's my fault, right? I don't know if you guys understand. If you use 90, I'm not going to take points. I'm going to say you should have used 80. But hopefully that makes sense. To be more conservative, we use the next one down. And can you guys look that up for me? What's 0.05 one tail test, right? 1 one tail. One tail. Let me check that. What do you get? 1.664?
Yeah.
Yeah. You guys get that? 1.664? Cool, cool. So T is 1.664. Negative, I like it. So it's down here. So let me just leave this as if T star. So here's negative 1.664. There's my rejection region. Then I've got to get at least that far away. Got to get, that's like my benchmark to pass. So if T star is greater than, less than? Less than. We can do what? Reject the null. Support the high. Oh, Jeff, you need a U there. There you go. So, I mean, the most important step in this whole thing is the fourth step, because it's the one that actually shows how far the sample got. And all they report to you next to the findings in a journal article will be the p-value. Right? That's what we're going to tell you, so you can make up your own mind. Is that big enough, or is that small, too big, whatever? Is it good enough to show evidence that you can make up your own mind? So that's what's going to be far enough away. And now we got to use that newest formula to figure out T star. Where are you at? You're about to stop. So step 4. The biggest mistake people make is they forget the poor little square dudes, right? So what's x bar 1? 11 minus 12 over 4.1 squared over n1, 3.7 squared over n2. If you put this all in your calculator at once, you better tell it what the top is, because your calculator ain't got eyeballs like you do. The day that happens will be a weird day. Calculator looks, some eyeball opens for I love it. Kids are going, I'm not sure how to take it. You should know it. All right, I got something. What'd you guys get?
Negative 1.21.
Yes, good. Negative 1.209, so 21, I like it. You might want to make sure right now that you can get that on your own. You can't put this in pieces, but when you do that, you tend to round each piece. And the more you round before you get to the end, the further off course you get. Those roundings play off each other and take your final answer way off the way. Did we make it far enough?
Yeah.
I couldn't understand that word. Do it again. Did we make it far enough? No. We had to make it this far. We only made it to there about.
Okay.
Right, negative 121. Now, real quick word about this. I can't actually find a p-value by hand here exactly because these are t-scores. And the t-score chart, I don't know if you realize this, is much less detailed than the z-score. I'd have to have a t-score chart for every degree of freedom that's as big as the z-score chart for it to be able to tell me as much information. I don't want that stack to carry around. So no thank you. So what's our conclusion? And what can we say right here real quick? Yeah, we didn't get it in there. So we failed to reject the null, failed to support the high. So which one am I going to use? Which wording? Yeah, because the claim was this guy, the high, so I'm going to use this language for it. I like it. So it's never a guessing game. It's just whichever one the claim is, that's the language I use. So we have not found evidence, sufficient evidence, to support the claim that the men's average is less than the women's average. It's not strong enough evidence. Now, somebody earlier asked me, does that mean that we accept the no? If I fail to reject it, does it mean we accept it? No. It's like if I fail to show that you're guilty of a crime, does that mean you didn't commit it? No, right? So that happens sometimes. But it's just not strong enough evidence to show that you're guilty. Therefore, the court says you're innocent. But what's the reality? Who knows? You could still be guilty. We just don't know. You didn't show enough evidence to show that you were guilty. Same thing here. We didn't show enough evidence to support that, but it could be true. We just didn't show enough evidence right now. How do you guys feel about it? I mean, the more you understand the basic hypothesis test, the easier this kind of thing is. It's just got a different formula right here. So on this handout, there's one side that says two means, and the other side says two proportions. Don't worry about this side. That's in section 10.3. We're not going to get there yet. So just do the one that says two means.